Welcome back to Mathematical Maths. So in today's video we're going to go through some more examples of integration, just so you have a bit more of an idea of how to do certain problems and stuff like that. And the next few videos will be a lot more about integration, and it's just so like we get a lot of integration out of the way, and later on we can do even harder integration problems. Anyway, start with the first one. We have the integral of x root x 1 minus x squared. Now, remember what I said last time, we always want to take substitute u with the thing that's in the most awkward situation. In this case, it's going to be 1 minus x squared. And that's because all of that is surrounded by something to the power of 1/2. Okay? So now what we're going to do is we're going to differentiate this, and we get du over dx equals minus 2x. And when we rearrange that, we have du over minus 2x equals dx. Now what we can do is substitute that back in as dx, and we're going to have the integral of root u x over minus 2x du. Now what happens is the x crosses out, and we're just left with the integral.
Why do the x's cross us out?
That's because they're the same thing, and anything over itself is 1.
Okay, good.
Now what happens is we're left with the integral of the root of u over minus 2. And when we do that, that's the same thing as writing u to the power of 1/2. And remember, anytime we integrate something, we add 1 to the power, then divide that by that power. So what we're going to do here is have u to the power of 3 over 2, divide by 3 over 2, which is the same as multiplying by 2 and dividing by 3. 2 minus 3, multiplied by 2. Now what happens is the 2's can cancel out, and we're just left with u to the power of 3 over 2 divided by minus 3 plus c. Okay? We'll be back in a second, and we'll go on the second example. Hi, welcome back. Now we're going to do the integral of e to the power of 5 minus x and then root e to the power of 5 minus x. Okay, so minus x root e to the 5 minus x. Now, a good thing with integration is always to see what you're given at the beginning. And in this case, we can actually simplify this. So if we say, in this case, we're not going to substitute, we're just going to put some values in and simplify it. So in this case, we'll say e to the power of 5 minus x is u. Then we'll substitute this in. We'll have the root of u multiplied by the root of u, like this, dx. Now, if we simplify this, that gives us the integral of u to the power of 3 over 2 dx. Now what we can do is we will just rearrange and have it in terms of du. So we're going to have the differential of u's, and du over dx equals e to the 5 minus x divided, then remember we need to divide by the derivative of the top, and that's just going to be minus 1 over minus 1, and that's just minus e to the power 5 minus.
Wait, where did the 3/2 come from? In the u?
Pardon?
The 3/2 in the u? You see, down, bottom, right. That.
Yeah. So what happens is we've had e to the u to the power
Yes.
of 3
1/2.
over 2 over 1/2. And then remember, anytime we're multiplying something, we just add 1 to the power, because that's like 2 over 2 plus 1/2, and that's just 3 over 2. So what we can do now is, if we rearrange this, we have du over e to the 5 minus x equals dx. So we're going to substitute this in. We're going to have du over minus e to the power of 5 minus x. So in this case, we didn't actually need to simplify at the beginning, because this would have been e to the power of 5 minus x, that's over minus e to the power 5 minus x. And in this case, those do just cancel out, and we're left with the root negative u root u. So what's going to happen in this example is we have this integral. Well, actually, remember, anytime we're integrating, we add 1 to the power, so it's 3 over 2u, then we divide by that, and that's 2 over 3, but we had the negative in the front. So we're just going to have to bring that down here. Then this is our final answer, plus c. We substitute the u back in now that we're done. We have 2 over 3 minus, then the u comes in, that's e to the power 5 minus x 3 over 2, and then we can just put that in. That's the same thing as writing 15 over 2 minus 3x minus 2 plus c. Okay, we'll be back in a second and we'll get on to the next integral. Welcome back. We're now going to do the next integral, which is this one. I encourage you to try it by yourself, but if you're struggling, we'll just do it and just follow through, and hopefully this helps. Right. So remember I said that you always want to substitute something in that's the most like in the worst position. In this case, it's also going to be the 1/2, as it were, was the 2 times before. So we're going to say u equals 1 minus x, differential, which should be pretty standard by now, it's just minus 1. Now we're going to have, we can rearrange this and say x equals 1 minus u, okay? Now, because we have this x squared on the top, it's kind of in an awkward position, because we can't really get rid of it or anything, so we're just going to square x, okay? So we're going to have 1 minus u squared over the root of u, and then we're just going to substitute this, so du or minus du equals dx, so we're just going to have du and the integral is negative, okay? Am I still in frame over here? Okay, so now when we expand this, we're going to have negative the integral, and that's going to be 1 plus u squared minus 2u. Okay, and that's all over u to the 1/2. Now what we can do is we can just simplify this into multiple integrals. So we can say negative, then the integral of 1 over 1/2 plus the integral of u squared over u to the power of 1/2 plus the minus the integral of 2u minus, as you can guess it, u to the 1/2. Now, if we simplify this here, we're just going to have the integral of u to the minus 1/2, and when we integrate this, we add 1, that's just 1/2. So then in dividing by 1/2, it's multiplying by 2 and adding and multiplied by 2 and dividing by 1. So we're going to be left with this. Then we have plus. This simplifies into the integral of u to the power of 3 over 2. And that's just, we add 1, and that's going to be 5 over 2, and that's just like multiplying by 2 divided by 5, 2 over 5, that's u to the power of 5 over 2. And finally we have minus 2 to the power of u 1/2, and then that's just going to be multiplying by 2 dividing by 3, so that's going to be 4 3 u to the power of 3 over 2. Now all we need to do is substitute back in the u's, but at that stage it's no real maths involved, you just have to continue the process. Okay, we'll be back in 1 second and we'll get done with the last question. Hi, welcome back. Now we're just on the very last integral, and this one's actually very easy. It's just, well, you'll see. So we're going to start, well, as normal, I encourage you to do the question by yourself, but anyway, here we go. So it's the integral of sine over 1 minus cosine of x. So in this case, we're going to substitute u as, well, we can put it as different things, but in this case, we're going to just make it 1 minus cosine of x. And when we integrate that, du over dx, that will just give us sine. So now we just have du over sine x equals dx. We substitute this into here, so we have sine x over sine, then 1 minus cos, or this is just going to be u, and that's the integral. Those cancel out, so now we just have the integral of 1 over u, and that's the same thing as saying du. That's the same thing as saying the ln of u plus c. We substitute the u back in, so it's just going to be the ln of 1 minus cosine of x plus c. And remember, that's the absolute value because we can't have negative cosine. Well, thank you very much for watching. I hope this was a helpful video, and we just went through different types of integrals and stuff like that. Anyway, don't forget to like, subscribe, comment, and yeah, Thank you for watching and stay mathematical.